start, let me ask you a question. Do you often get confused with the direction of different forces acting on an object when drawing a free body diagram? Or the final answer you work so hard to get ends up wrong just because of the incorrect free body diagram drawn at the beginning? If your answer is yes, don't worry. Let me, Bong Jingning,
and I am Mohd Farihin bin Roslan,
PAL leaders from No.1 Matriculation College, introduce the FBD's hand rule to you with the aim to solve the questions involving free body diagram. According to the observation and surveys conducted during PAL sessions, we find out that many students show confusion when solving questions involving free body diagram. And they don't have their own technique in sketching a free body diagram as well. To deal with this problem, we have done some research on the most effective learning method for the Gen Z group, and we find out that students may acquire knowledge in 3 ways, which are watching, listening, or doing. These 3 learning styles make up the VAK model that stands for visual, auditory, and kinesthetic respectively. And that's why we came up with this method, FBD's hand rule, which basically focuses on visual and kinesthetic with the aim to help the students in solving questions involving free body diagram.
So, let me introduce you to FBD's hands rule. But before that, what is FBD stand for? FBD stand for free body diagrams, which basically means that these techniques will only focusing on answering free body diagrams part, which is the first step before you want to solve any kind of equations in this chapter. So, to use these techniques, you only need to know 3 things. Everyone can follow me. So the first thing, you need to use your own hand and a pen. The second, you can make your hand look like a pistol like this and hold your pen here loosely. So the last thing is, you need to know what each direction and what each forces represent by each fingers. So let me explain. The first finger here, which is the thumb, will represent the 4 normal forces acting on the object. The pointing and the middle finger here will represent the force applied to an object or a tension. The other 2 fingers here will represent the frictional forces, and the pen here will represent the weight of an object that will always pointing downwards because we held it loosely. So it's easy, right? How about we try this FBD hands rule on the first example. So as you can see, the first example here, that this object is being moved by a force to the right. So to apply these techniques, we only need to point our finger, which represent the force applied to an object, same as the equations given, and attach it to the image of the equation, and now we can see all the forces acting on the object will follow the true directions of each forces. Just as simple as that. So how about if the second example here, if an object being pulled on an inclined plane, same as before, we only need to determine where the directions of the forces applied to an object. So since it goes to the top right corner, we only need to point our hand to the top right corner. To the top right corner here, and all we can see now, all the forces acting on the object will follow the true directions of the forces, which is normal forces will always perpendicular to the surface, force applied will always following the force applied to an object, the frictional forces will always opposite directions to the forces, and the weight of the object will always pointing downwards. That's how student can draw free body diagrams easily with FBD's hands rule. But how about the effectiveness on these techniques?
Last but not least, we have collected some feedbacks from the students to gain an insight on the effectiveness of our technique. As you can see, they managed to solve the questions involving free body diagrams successfully after implementing this technique. They also think that this strategy is so simple and convenient to be applied, especially during examinations. As a proof, these are the distributions of the score of the students before and after we introduce the technique to them. Their results increased by 51.7%, and this shows that our technique works well in helping the students to answer questions involving free body diagram. By now, we shall end our presentation here. Always remember that together we struggle,
together we strive, may the PAL
be with you. Thank you.